Hi, my name is Bob Stern, and I'm Professor of Geosciences at the University of Texas at Dallas. I am deeply honored to be awarded the 2019 International Prize of the Geological Society of Japan. While I cannot be with you in person, I can share a video explaining how someone who lives and works in Texas, so far away from where you are, came to do something of interest to Japanese geoscientists. For the next 20 minutes or so, I will tell you how I became interested in the Izu-Bonin-Mariana Arc and some of the excitement I experienced during the 15 times I went to sea to study especially the Mariana Convergent Plate Margin, most of them on JAMSTEC research cruises. My work in the IBM Arc began in 1976 when I was finishing my second year as a graduate student at the Scripps Institution of Oceanography. A few years earlier, I had taken an undergraduate class at the University of California, Davis, taught by Eldridge Moores and Gerard Bond on global tectonics. They told us, among other things, about Dan Carrick's shocking idea of how some island arcs split apart to form something called a back arc basin. Just as fascinating to me was the fact that Carrick came up with this idea while he was a graduate student at the Scripps Institution of Oceanography studying the Mariana Convergent Plate Boundary. This made me want to become a graduate student at Scripps and study the Mariana Arc. I was most fortunate to be accepted by Scripps as a PhD student in 1974, but it took me a couple of years to arrange a field trip to the Marianas. Of course, the Mariana Arc is an excellent example of a convergent plate margin built above a subduction zone, and these are important topics of scientific study. In the summer of 1976, I, along with fellow grad student Tim Dixon and Aaron Meyer, a Caltech postdoc, flew to Saipan. We rented a small fishing boat that took us north to visit several of the Mariana volcanic islands, including Sarigan, Guguan, Alamagan, Pagan, and Ascension. We stayed for several days on one of the biggest islands, Agrigan, one of the few that was populated. A U.S. Navy ship picked us up and took us back to Guam, where Tim and I joined a dredging expedition to the Yap Trench led by Jim Hawkins. When I returned to Scripps, I did my PhD on the Precambrian basement of Egypt under Al Engel, but half of my scientific heart was still in the Marianas. My first scientific paper was about the volcanics of Agrigan. As a postdoc at the Carnegie Department of Terrestrial Magnetism, I worked on Egypt and Mariana samples, including some young lavas that Dale Bibee and Tim Dixon had dredged from submarine arc volcanoes. In summer of 1981, I visited Japan for the first time to attend a volcanology conference in Hokkaido and go on a field trip. After that, I was able to spend a week on Iwo Jima studying its geology and contemplate the terrible battle that was fought there 75 years ago. In 1982, I moved to the University of Texas at Dallas as an assistant professor to help run the radiogenic isotope lab with Willy Manton. A few years later, I got a telephone call from Sherm Bloomer, who told me that the manned submersible Alvin was going to the Western Pacific and that we should write an NSF proposal to dive on some of the submarine volcanoes. We submitted the proposal, but were declined. However, NSF encouraged us to revise our proposal and start by dredging Mariana Arc submarine volcanoes. About this time, it became much easier to find submarine volcanoes because U.S. Navy swath maps were starting to be released to U.S. marine geologists. We wrote that proposal and we were funded. And in November of 1985, we led a month-long expedition aboard the research vessel Thomas Thompson. The TT-192 expedition sampled 31 submarine arc volcanoes along 1,200 kilometers of the southern IBM arc, starting with Ruby Volcano at 15 degrees 30 north to Nishinoshima at 27 degrees north, recovering enough material for a lifetime of research. Koichi Nakamura of the Geological Survey of Japan helped us a lot on that cruise and showed how rewarding it could be to work with Japanese geoscientists. Sherm and I led another NSF-funded expedition in December 1991 aboard the research vessel Thomas Washington to study and sample the northern Mariana Trough back arc basin extension axis. The Toon 7 expedition swath mapped and sampled for 700 kilometers from 19 degrees north, where seafloor spreading occurs, northward into a zone of amagmatic and then magmatic extension. This region included a very unusual region of shoshonetic volcanism that ends at Iwo Jima. We interpreted what we found as reflecting the northward propagation of the Mariana back arc basin extensional regime. During this cruise, we discovered a deep rift zone about 130 kilometers long at the north end of the spreading ridge, a feature that Fernando Martinez at the University of Hawaii had called the Central Graben. I was puzzled by this rift and contacted Toshitsugu Yamazaki from the Geological Survey of Japan, who had worked in the region. He was co-author on a 1996 paper about the rift and its rocks, the first of my 35 papers published with Japanese co-authors. In summer of 1996, Makoto Arima of Yokohama National University and I helped organize a U.S.-Japan workshop on the IBM ARC system, which was held at the Hakone area over 4 wonderful days. This workshop introduced 10 U.S. and 75 Japanese scientists to each other's work and set the stage for a decade of research under the NSF-funded Margins program, which began in 1998. The U.S. scientific community chose the IBM ARC as one of 2 focus sites for the subduction factory experiment. The Margin subduction factory focus site in the IBM convergent margin benefited greatly from the strong partnership between U.S. and Japanese scientists. The Hakone meeting also helped me meet and collaborate with Japanese geoscientists. In 1997, I joined my first JAMSTEC research cruise aboard the research vessel Yokosuka with Toshi Yamazaki to study the Mariana back arc basin, including the Central Graben. In 1998, Makoto Arima and I tried to use the research vessel Natsushima and man-submersible Shinkai 2000 to dive on shoshonetic volcanoes of the Hiyoshi complex, but were chased away by a typhoon. It was a great trip anyway because we got to visit beautiful Chichijima, and I had my first experience doing marine geology with a remotely operated vehicle, or ROV. In spring of 2001, Sherm Bloomer and I led the Cook 7 expedition in the Marianas aboard the research vessel Melville. We swath mapped bathymetry and sonar backscatter in the arc and back arc basin south of 18 degrees north, then used these maps to dredge arc and back arc basin volcanoes. We dredged with a pinger, but somehow lost one while dredging a seamount west of Saipan. Results of the Cook 7 expedition were very useful in planning future cruises using ROVs. The 6 years between 2004 and 2010 were wonderful because I got to work with U.S. and Japanese colleagues to apply modern technology to studying the Mariana Arc. This episode began with a NOAA cruise, but most of the work was with JAMSTEC. In spring 2004, UTD grad student Neil Basu and I joined NOAA's Submarine Ring of Fire expedition above the research vessel Melville, led by Bob Embley. The year before, NOAA had searched the Mariana Arc and Back Arc Basin for hydrothermal vents using CTD Toyo techniques, and in 2004, we returned to visit some of the potential seafloor vents using a Canadian ROV called Ropos. The first site we visited was Northwest Rota 1, which we were amazed to discover erupting from a deep pit near its summit, 500 meters below the sea. With Ropos, we could watch as the ash and molten sulfur droplets were ejected from the erupting pit. We continued north to examine the East Diamante caldera, where we discovered tall chimneys with black smokers a few hundred meters below the sea surface. This site was also fantastic because here the transition between photosynthetic and chemosynthetic communities could be examined. We continued north to look at the source of another hydrothermal vent at Northwest Aifuku volcano. Here we found bubbles of liquid carbon dioxide streaming out of the seafloor, 1,650 meters below the sea. It was amazing to watch the sticky bubbles accumulate on the ROV's camera. Also in 2004, Sherm Bloomer, Mark Reagan, and I began diving with Yasuo Ohara and Osamu Ishizuka on the IBM 4-arc using the research vessel Yokosuka and Shinkai 6500. We began diving west of the Ogasawara Islands during JAMSTEC cruise YK0405. We dove at several sites on a 3,000 meter tall scarp, where we discovered Eocene high magnesium andesites transitional between the slightly older bonanites of Chichijima to the east and Oligocene arc volcanics to the west. These results helped convince us of the need to propose drilling on the 4-arc to the east, which led to IODP leg 352, drilled in 2015. After YK0402, we began studying the southern Mariana Arc near Guam. In late summer of 2006, Yasuo Ohara led us on YK0612 to dive on the Mariana 4-arc southeast of Guam in an effort to better understand its crustal structure. We had 5 Shinkai 6500 dives between 6,500 and 3,000 meters, recovering crust and upper mantle samples. Results from this cruise were very important for stimulating our thinking about how new subduction zones form. In July of 2008, we returned during YK0808 to the Mariana 4-arc farther south of Guam, with 7 dives of Shinkai 6500 on the other side of the prominent north-south Santa Rosa Bank fault. We now know that this fault separates very different 4-arc tectonic regimes: stable Eocene lithosphere to the east and younger tectonically active 4-arc to the west. 4 dives to the east observed and sampled crust and upper mantle like that we'd studied farther north in 2006. But 3 dives to the west discovered basalts that were much fresher than the Eocene 4-arc samples we had seen previously. This was our first hint that the 4-arc to the southwest of Guam was very different than that of the rest of IBM. Argon-argon dating by Osamu Ishizuka demonstrated that these basalts were indeed young, only 1 to 2 million years old. YK1012 in September 2010 carried out 8 dives each using Shinkai 6500 and the YK Deep Tow package to study a 160 kilometer long segment of the southern Mariana Forearc. On this cruise, we discovered the Shinkai Seep Field, an unusual low-temperature venting site with brucite and carbonate chimneys and lots of life around the vents. At the same time we were diving with Shinkai 6500 in the Forearc, we were also using an ROV to explore arc volcanoes. In fall of 2005, Sherm and I began a fruitful collaboration with Yoshi Kimura at JAMSTEC. The NOAA Submarine Ring of Fire experience convinced me that using an ROV was the best way to study submarine arc volcanoes, which usually reach to within a kilometer or so of the sea surface. Over the next 5 years, I would be lucky enough to sail on 4 expeditions using the research vessel Natsushima and the ROV Dolphin 3K. These expeditions were dedicated to learning more about submarine arc volcanoes in a 500-kilometer-long region between Guam and Pagan. I very much enjoyed serving as a member of the scientific team led by Yoshi Kimura aboard the research vessel Natsushima, and we were able to involve many other U.S. and Japanese scientists and students. We began our exploration during the 2005 NT-0517 expedition above the research vessel Natsushima. NT-0517 carried out 10 ROV dives on 5 southern Mariana submarine volcanoes, concentrating on the huge West Rota caldera discovered during Cook 7. We also dived on the interesting 14-degree north, 40-minute north cross chain, where we found some of the most interesting and primitive arc lavas ever recovered from the Mariana Arc. In February of 2009, we returned with the research vessel Natsushima and Dolphin 3K ROV during NT-0902. Tracy Volcano is only 30 kilometers west of Guam, but it was unknown if the volcano was active, dormant, or extinct. We dived on it and discovered it was extinct. We dove 4 more times on West Rota caldera to better understand its alteration and mineralization. We also returned to West Rota volcano and saw that it was still erupting. In June of 2009, we sailed again with the research vessel Natsushima during NT-0908, conducting 17 ROV dives on Mariana submarine arc volcanoes between 15 degrees 50 minutes and 17 degrees north, concentrating on 2 big felsic igneous complexes, East Diamante and the Zealandia volcanic complex. NT-1012 in July of 2010 conducted 11 ROV dives to study 6 submarine Mariana arc volcanoes between 18 degrees 10 minutes and 13 degrees 30 minutes north. We were excited to discover young pillowed basalts at 3,000 meters water depth on the northern flank of Pagan Island while we watched smoke come out of this active volcano. 2010 was the last year I went to sea. I have a nervous disorder called Charcot-Marie Tooth syndrome that progressively affects my legs and arms. It was becoming harder and harder for me to manage on a rocking and rolling ship at sea, and I knew that it was time to stop. Nevertheless, I continue to work on problems related to the IBM convergent margin, and I hope to do so as long as I live. Thank you again for recognizing my work with the 2019 International Prize of the Geological Society of Japan. It is clear that this recognition should be shared with many, many other people who I wrote proposals with, sailed with, worked on samples with, gave talks with, and wrote papers with. Some of their names are listed at the end of this video. There is one person who I must thank here, and that is Melissa Fenton, my loyal and loving wife of 42 years. She gave me a wonderful family and took care of everything while I was at sea or at meetings. She made it possible for me to do some things in science. Again, Thank you for this award, and thank you for listening.